So the last video related to chapter 15 is where we're going to walk through the calculations for how to do the future value and present value of these annuity cash flow. So again, the previous video kind of gave us an introduction of what an annuity is on this slide, and then we're going to move into slide 8 that talks about giving us some scenarios to do future value calculations of these annuities and then present value calculations of these annuities. So here's the situation that we're going to look at. We have a person who wants to accumulate a sum of money to pay for graduate school. So rather than investing a single amount, she decides that she's going to invest $10,000 a year over the next 3 years in a savings account that's going to pay 10% interest, and it's going to compound annually. And what we're going to calculate is, in scenario number 1, if she decides to make the first payment into that investment account 1 year from today, so that would be in the instance of, again, when we're trying to decide whether we have an ordinary annuity or an annuity due, scenario number 1, if she's making that first payment 1 year from today, that's essentially the end of the first period, so that's going to be an ordinary annuity. And then we're going to do it again, scenario 2, and we're going to see what the differences are if she decides to make the first payment on day 1. And when the payment is made on day 1, that's going to be annuity due. So that's the scenario that we're going to then carry into our Excel spreadsheet. So if we look at the final tab, the annuities tab, you can see, first of all, I've given a little timeline to kind of just give, I'm a visual learner myself, so I like to look at timelines and pictures and things like that to kind of help me understand. And you can see the difference between an ordinary annuity and an annuity due. An ordinary annuity, the payment, whether it's being received or paid, the cash flow is coming in at the end of each of the years, and then with an annuity due, the payment or the receipt of cash is happening at the beginning of each of the periods. So when we talk about using the future value formula, so again, you can see below, by the way, that we're going to also do the present value of annuities, but first we're focusing on future value. So we want to know if this individual invests $10,000 at the end of each period. So first we're going to do the ordinary annuity at the end of each of the next 3 years, and they can earn interest of 10% annually. How much would they accumulate over time given those investments? And the way, again, we can do that is with the same equals FV formula that we used in the very first video that we went through. So FV stands for future value. That is what we are trying to solve for. In this instance, they again prompt us, Excel, not they, but Excel prompts us for the data that is needed for the calculation. Our rate is 10%. Our number of periods is 3, and remember that the number of periods is not necessarily years, it's how many compounding periods, but just in this example, there are 3 years and we only compound once per year, so the number of periods is only 3. PMT stands for payment. So far in our examples, we have not used this. Now we're going to see a negative $10,000 as our payment amount. And the reason why it's negative is because in these scenarios, what we're assuming is that this individual has cash out of their pocket. Each individual $10,000 represents cash payment into this investment account. And what we will see in the resulting calculation is going to be a positive amount. That means how much will she be able to extract out, or how much inflow will she have of cash once she invests these funds for the next 3 years with an interest rate of 10%. So our PMT is $10,000. Our PV is 0. We don't have a lump sum amount that we're referring to here. We just have a payment amount. And then type. Remember what we said, that in these annuity calculations, what we have to consider is the type, and we have to decide whether we have an ordinary annuity or an annuity due. In this situation, because the payments are happening at the end of every period, this is an ordinary annuity. And for ordinary annuities, we use 0. If we input all of that information, what we are saying is that if that individual invests $10,000 over the next 3 years, and they invest it at the end of each year, earning an average of 10% annually, that cash would accumulate to $33,100. So that's the future value of those periodic investment payments that this individual would be making. Now, let's think about this in terms of an ordinary or annuity due, right? If the individual is making the first payment on day 1 of year 1, right? That's when the first payment is being put into the investment account. We can think to ourselves that this individual would have 1 full year of a return that they got that they did not get with an ordinary annuity. So we can set an expectation that when we do the same exact calculation, except we use an annuity due instead of an ordinary annuity, we can expect that what comes out in that orange box is going to be higher than $33,100. And again, that's because with an annuity due, that individual is getting 1 full year's worth of interest, 1 full year of a return that they weren't getting with an ordinary annuity. So if I do the calculation, equals FV, again, Excel basically just prompts you for what they need. 10% is my interest rate. My number of periods is 3. My payment amount, again, I'm going to put a negative $10,000 because it's cash out of the pocket of the investor going into the investment fund. We don't have a lump sum amount present value that we're also investing, so present value is 0, and now my type is going to be 1. For an annuity due, the type is going to be 1. And lo and behold, we see that we are able to earn a higher amount, right? The future value accumulates to a larger amount because we are investing that money at the very beginning. The very first $10,000 is happening on day 1. Therefore, we are earning a return on that $10,000 that we were unable to earn when we had an ordinary annuity. So we were able to accumulate the future value of those periodic investments was $36,410. So that's the future value. Now we're going to move on to present value of an annuity. So if we go to our final slide, so now here's the situation. We want to be able to invest a single amount today in a savings account. The single amount that we want to invest today is our present value. And the idea here is that we don't know what that is. We don't know what the present value is. We have to figure that out in our calculation. That's why the formula that we're going to use is going to be equals PV. So we want to invest a single amount today, and we can assume that that single amount will earn a 10% interest annually. And what we want to be able to do is extract $10,000 out of that fund every year for the next 3 years. We are going to go through these scenarios again where we have either an annuity due or an ordinary annuity. Scenario number 1, we want to take out that $10,000 at the end of each year. So that's going to be our ordinary annuity. And then scenario number 2 is when we want to take out that first $10,000 at day 1. On the very first day, we want to be able to extract that first payment of $10,000 out. So that's going to be an annuity due. So all of that data is included in our Excel spreadsheet. And now, again, the same way that we did with the present value tab in the previous video, we're going to use the equals PV formula. And again, what we're trying to decide here is how much would we have to set aside in this fund today if over time we wanted to be able to extract $10,000 out of it over the next 3 years, and knowing that we can earn interest, we can earn a 10% return on the money that we invest today. So we're going to use equals PV because we are trying to solve for what that present value amount is that we need at the beginning in order to be able to take out those $10,000 annual payments, those $10,000 annual amounts at the end of every year. My rate, again, is 10%. My number of, it's not letting me, there we go, 10%. My number of periods is 3. My payment, again, is $10,000. That's the amount that I want to be able to extract out of this fund every year. My future value, there's not some lump sum amount that I also want to be able to get out of this, so I have a 0 future value. And again, because this is an ordinary annuity, my type is going to be 0. What we are saying is if we wanted to be able to extract out $10,000 at the end of every year for the next 3 years, we would need to set aside $24,869 now. And let's think about this in terms of overall cash flow, right? This is the cash outflow that we would have to put in that investment account, and that over time it would accumulate interest so that 3 times in the next 3 years we would be able to take out $10,000. And so in our pockets we would have $30,000. So by investing $24,000 now, we would be able to extract $30,000 out of that fund over the next 3 years. So let's do the same scenario, except let's do it for an ordinary, or I'm sorry, for an annuity due. So we're going to do, again, equals PV. We are solving for the present value. Our rate is 10%. Our number of periods is 3. Our payment amount is $10,000. That's how much we want to be able to take out of that fund every year for the next 3 years. Our future value is 0, and now our type is 1. We want to be able to take $10,000 out of that fund on day 1. So notice, our initial outflow, even for the same total amount of cash flows, right? 10,000 times 3 times we're going to do that. Our total cash flows out would be $30,000. That's how much we would be able to get out of that fund. Because we want to take that first $10,000 payment out on day 1, we have to put more in the fund. We have to set aside more, the present value. We have to set aside more in that fund today because of simply when we want to be able to extract those payments. So again, this lecture is simply to introduce us to how to do the calculations. We are then going to apply the knowledge, especially when it comes to these present value calculations. We are going to apply this knowledge when we start thinking about how to account for long-term liabilities where we have all these different outflows of cash that are way out into the future, and we need to know how much they're worth today. That's where these present value calculations are going to come into play more specifically when we get into the chapter 14, 15, and 17 lectures.